Welcome to Study Loop.
Hey, this is question 28.64. We have one long wire up here with current that I'll call I1 that has a current of 14 amps. And then we have this wire loop down here with current I2, which I'll call this current I2. And I2 is 5 amps. And we want to know what the force is on the wire, on this loop of the wire, caused by this long wire up on the top. So to do that, we're going to need to use our equation for the force on two segments of wire. And we want to know the actual absolute force. So let's multiply both sides here by L so that we are just solving for the force directly. Now, since these wires in this loop are separated by just different distances, we're going to need to consider each side of the loop separately. So let's first think about these two horizontal lines over here, the two vertical parts of the loop. If you think about it, the magnetic field exerted on both of these from this wire loop is going to be the same, but the current in either of these is in opposite directions. So when we add up the sum of the force on this wire and the sum of the force on this wire, we're going to get two values that are equal in magnitude but opposite in direction. So one of these is going to be negative and one will be positive. But that means that they're essentially just going to cancel out because they're equal in magnitude but opposite in direction. So we can just ignore these two vertical parts of the loop because they're not going to contribute anything to the force. They're just going to cancel. So now let's consider, we're going to have to just add the force on the top to the force on the bottom. And let's just think about this conceptually. We have the force on the top. We have two wires that are going in the same direction, with currents going in the same direction. And when we have two currents going in the same direction, they will attract each other. So this is going to be an attractive force. But on this bottom wire, the currents are going in opposite directions from the original wire. So that means that these ones are going to repel. So the direction of the force exerted on the top is going to be the opposite of the force exerted on the bottom. So when we add these together, we're just going to want to make sure that we'll consider this to be positive, and then we want to subtract the value from this. So the fact that the currents are in opposite directions means we're going to need to make sure that this term is negative. So now that we've established that, let's actually go ahead and do that. So let's consider the force on the top wire first. So we have our I1, which we know is 14 amps, our I2, which we also know. The length is going to be the length of this wire, so we'll know that as well. That'll be just 20 centimeters. And now we need 2 pi r, so the distance between the distance from this first wire to the top wire. So that's 2.6 centimeters, which is going to be 0.026 meters. So that's what we're going to have down here. So this is the force on the top wire. And then remember, we want to just subtract the magnitude, subtract the result of the force exerted on this bottom wire. So the bottom wire, everything is the same. We have the same current, except again, it's going in opposite direction, which is why we bring in this negative sign. And now the distance is 10 centimeters, so 0.1 meters. And we can simplify this a bit before we actually go through and plug in everything to solve, because we have this factor of mu naught I1 I2 times L divided by 2 pi in both of these terms. And then we just have 1 over 0.026 minus 1 over 0.1. So this is what we're going to plug in here. And again, we're just looking for a magnitude. So we just want to take the absolute value of our result here. And this is going to give us 7, let's just make sure that we are sure that we know everything that's plugging in. So I'm just going to explicitly say that L here, we're going to have to plug in as 0.20 centimeters, which is 0.2 meters. So now we explicitly have everything here to plug into our equation. So now when we plug in and solve, we will get the force is equal to 7.97 times 10 to the minus 5 newtons. And again, we have, we're told that these, we essentially have, when we were considering the direction, we know that this top part of the loop is closer to this wire. So since we have, so the force on this top part is going to dominate. So since the currents going in in the same direction attract, this loop is going to experience a force upward because it's going to be net attracted to this top wire since the bottom wire is farther away from it than this one. So this is going to be a force upward.